We shall be discussing exercise 5.3 of NCERT, class 12th of maths. Let's begin. The first question says 2x plus 3y is equal to sine x. We will differentiate both sides with respect to x. D by dx 2x plus 3y is equal to d by dx sine of x. Now d by dx 2x plus d by dx 3y will be d by dx sine of x. D by dx 2x will be, what is the answer? 2. Now d by dx 3y will be 3 as it is, multiplied by dy upon dx. Now what is the derivative of sine x? It is cos x. Now here we take 3 into dy by dx on the left hand side and we take 2 towards the right side. So we get is equal to cos of x minus 2. Taking 3 towards the other side of the equation, answer will be dy by dx is equal to cos x minus 2 whole upon 3. A very simple question. Second question. 2x plus 3y is equal to sine of y. Now differentiating both sides with respect to x, we have d by dx 2x plus 3y is equal to d by dx sine y. Now what is the derivative of 2x? Answer will be 2, and derivative of 3y, we will write 3 as it is, multiplied by dy upon dx is equal to, what is the derivative of sine y? Answer is cos y. Because here is y, so we will multiply it by dy by dx. On the same grounds, 3y may also, we wrote dy by dx separately. Here also, first we will write the derivative of sine y, which will be cos y, and then multiply it by dy by dx. Now we see that this term has dy by dx and this term has dy by dx. Taking both these terms together, take cos y dy by dx towards the left side of the equation. We get 3 dy by dx minus cos y into dy by dx, because it will cross this, it will turn to negative, and this 2 will come on the other side of equation, it was also go negative. Now if we take this area, take dy by dx common, bracket starts 3 minus cos y is equal to minus 2. Now you take this whole set towards the other side of the equation, we will get dy by dx is equal to minus 2 whole upon 3 minus cos y. This will go in the denominator. Now from the denominator, you please take minus as common. So you will write minus 2 upon minus cos y minus 3. So this minus and this minus get cancelled off, and the answer is 2 upon cos y minus 3. In general, whenever we get the answer in the negative, we try to make it in the positive form. So what we did here was take minus common in the denominator and then cancel it with the numerator, and we get a positive answer, which is 2 upon cos y minus 3. Next question. See, ax plus by square is equal to cos y. We will follow the same pattern. Differentiating with respect to x on both the sides, we get dy by dx ax plus by square is equal to d by dx cos of y. Now we will calculate the differentiation here. What is the derivative of ax? We will get a, right? Now the derivative of by square will be 2by multiplied by dy by dx, which is equal to the derivative of cos of y will be taken as minus sine y multiplied by dy by dx. Wherever you are getting here y, you will first solve the derivative and then multiply it by dy by dx. Here also you did the same thing, and the same was repeated here. First calculate the derivative of cos y, answer is minus sine y, then multiply it by dy by dx. The next step is just take the terms which are having dy by dx towards one side of the equation and the other terms on the other side of the equation. So we will be getting 2by into dy by dx plus, because it is minus on this side, it will turn plus, sine y into dy by dx is equal to minus a. A was positive here, but when it will come towards the other side of the equation, it will turn negative. Very simple. Now please take dy by dx common from both these terms. So you will get bracket starts 2by plus sine y is equal to minus a. This will go in the denominator. Answer will be minus a upon 2by minus sin y. Again, a very simple question. Next question number 4. Xy plus y square is equal to tan x plus y. Differentiating both sides with respect to x, we get d by dx xy plus d by dx y square is equal to d by dx tan x plus d by dx of y. Now this xy, it will be termed as the UV formula. X as it is, first term as it is, multiplied by the derivative of the second term, which is dy by dx, plus second term y as it is, multiplied by the dy by dx of the first term, which is derivative of x, we get 1. D by dx y square, you will get 2y into dy by dx is equal to, what is the derivative of tan x? It is sec square x. We write it here, plus dy by dx. Right? Because the derivative of y will be written as dy by dx. Now, we see one term, two term and these three terms are having dy by dx. Getting them together, this term here, which are already towards the left hand side, just get this term towards this side of the equation and it will turn negative. So you get x into dy by dx plus 2y dy by dx minus this term dy by dx is equal to sec square x as it is, and this y will come towards the other side and it will turn negative. Now you just take dy by dx common from these three terms. You get dy by dx bracket starts x plus 2y minus 1, because this you will get here 1. This is equal to sec square minus 5. Now this term you take it towards the right side and put it in the denominator. You will get dy by dx is equal to sec square y whole upon x plus 2y minus 1 is your answer. Next question. Fifth question. X square plus xy plus y square is equal to 100. You differentiate both sides with respect to x. We get d by dx x square plus xy plus y square is equal to d by dx of 100. Now what is the derivative of x square? We get 2x. Derivative of xy will be calculated in the UV formula. So we write here d by dx xy. What is the derivative of y square? It will be 2y as it is multiplied by dy by dx. This is equal to the derivative of 100, which is a constant. It will be taken as 0. Now putting 2x as it is, put a bigger bracket. Now how you will calculate the derivative of this term? It will be the first term, which is x as it is, multiplied by the derivative of the second term, which is y. You will get dy by dx plus second term as it is means y as it is multiplied by the derivative of the first term, which is x. Answer is 1. So you get 2x plus x into dy by dx plus y into 1 plus this term as it is 2y into dy by dx is equal to 0. Now you please open this bigger bracket. So you will get 2x plus x into dy by dx plus y plus 2y into dy by dx is equal to 0. Now we see these, I have ticked these terms. One term here containing dy by dx and the second term here containing dy by dx. Please take dy by dx common in this. You are left with x plus 2y. This term 2x, it will go towards the other side of the equation. It will turn negative. Y, it will also go towards the other side of the equation. It will turn negative. So you are left with dy by dx x plus 2y is equal to minus 2x minus 2y. Now in the right hand side, please take minus common. You are left with minus bracket starts 2x plus y. X plus 2y will go towards the other side and it will be fitting in the denominator. So the answer will be dy by dx is equal to minus bracket starts 2x plus y whole upon x plus 2y is the answer. Again, a very simple question. Now question number 6. This seems a little tough, but it is equally easy. See, x cube plus x square y plus xy square plus y cube is equal to 81. Listen very carefully. Differentiate with respect to x on both the sides. We get d by dx of the whole term is equal to d by dx 81. Now, we will take term by term. D by dx x cube, you will get the answer 3x square. Okay. Now, d by dx x square y. This will be calculated in the UV formula. What you will write is First term as it is, it means x square as it is. Derivative of the second term is y, it will be dy by dx plus second term as it is, y as it is, into the derivative of the first term which is x square. The derivative of x square is written as 2x. So this d by dx x square y is calculated in this area and this is the answer. Now coming to the next term here, it is d by dx x y square. This will also be calculated in the UV formula. What you will do is, first term x as it is multiplied by the derivative of the second term y square. Y square derivative is 2y as it is multiplied by dy by dx. So please don't forget to add dy by dx whenever you do the derivative of y. Okay, so we get x into 2y dy by dx plus second term as it is, which is y square as it is, multiplied by the derivative of the first term. The first term is x, the derivative answer is here 1. So the d by dx x y square is calculated in this area. Okay. Now next we come plus 3y square dy by dx. This is coming as it is in this side is equal to 0. Now what we do is, please open this bracket and also open this bracket. Let's see what we get. 3x square plus x square dy by dx plus this y into 2x will come 2xy. Again x into 2y into dy by dx will get 2xy into dy by dx plus this y square into 1 you will get y square plus 3y square dy by dx, it will come as it is equal to 0. Now I have underlined the terms which are carrying dy by dx. This is the first term, this is the second term and this is the third term. So what you do is, please take dy by dx common. You are left with this term x square, this term 2xy and this term 3y square. I have ticked the terms which are not containing dy by dx. There are three terms, 3x square plus 2xy and plus y square. All these three terms will go towards the other side of the equation and they will turn negative. So you are left with minus 3x square, minus 2xy and minus y square. Now in the next step, left hand side of the equation will be copied as it is and in the right hand side please take minus common. So you are left with minus bracket starts 3x square plus 2xy plus y square. Now what is here, this term, when it will cross this equation, it will go in the denominator. So ultimately you are getting the answer dy by dx is equal to minus bracket starts 3x square plus 2xy plus y square whole upon x square plus 2xy plus 3y square is the answer. Next question. Question number 7. The question is sin square y plus cos xy is equal to k. The same pattern will follow. Differentiating with respect to x on both the sides, we get d by dx sin square y plus d by dx cos xy is equal to d by dx k. Now d by dx sin square y, let us calculate this funda separately. So here I have calculated d by dx sin square y. This is equal to, see this square, it can be written as d by dx sin y whole square. So this square which is just put it here, sin square y, it can be equally written as sin square in the bracket power 2. Okay. Now how will you solve it? This sin y whole square ka derivative you will calculate it by this method. D by dx x power n is equal to n into x n minus 1. So here this sin y will be taken as x. So what will be the answer? It will be 2 into sin y power 2 minus 1 multiplied by d by dx sin y. So please make it sure that what is given in the bracket, uska derivative will be calculated separately. So answer is 2 into sin y 2 minus 1 multiplied by d by dx sin y. Whatever is there in the bracket, the derivative will be calculated separately. Now this will come out to be 2 sin y 2 minus 1 will be sin y. Okay. And what is the derivative of sin y? Answer is cos y into dy by dx. Now generally what the students do the mistake here is, sin y derivative they will write cos y but they will forget to write dy by dx. Whenever I am repeating, whenever you will be calculating the derivative of y term, you have to insert dy by dx. So now this term sine square y derivative, I have calculated 2 into sine y into cos y into dy by dx. Now the second term derivative also I have calculated separately, d by dx xy, cos xy. So d by dx cos of xy will be calculated as, answer is minus sine xy into d by dx xy. See, the derivative of cos x is minus sine x. So now the question is cos xy. So what you will write is minus same way, sine same way. Instead of x you will write xy multiplied by d by dx xy. Now this minus sine xy will come as it is here. And how will you calculate the derivative of xy? You will again use a UV formula. You will write minus sine xy as it is outside the bracket, then first term x as it is multiplied by the derivative of the second term which is y, and the derivative come out to be dy by dx, plus second term as it is, it means y as it is multiplied by the derivative of x which is 1. So you are getting minus sine xy, bracket starts x into dy by dx plus y. Now please open the bracket, you will get minus sine y x dy by dx minus sine xy into y. Here you will write x in the forward term, you will write minus x sine xy into dy by dx minus y sine xy. So be very careful in calculating their respective derivatives. Now putting the values of these two derivatives in this equation number 1, I will get what is the derivative of the first term. It is 2 sine y cos y dy by dx. Here it comes 2 sine y cos y dy by dx. What is the derivative of the second term? It is minus x sine xy into dy by dx minus y sine xy. So this answer has been copied here and this answer has been copied here, which is equal to 0, because k being a constant, the derivative will be 0. Now we know another formula, that 2 sine x cos x is equal to sine 2x. We will put this formula in this underlined portion. You have 2 sine y cos y. What you will get? Sine 2y. Using this formula, this all thing will be written as sine 2y into dy by dx. Rest of the term will come like this only, but minus sine xy dy by dx will retain here on the left hand side of the equation, and y sine xy will go on the other side of the equation, so it will turn positive. Minus sign will get positive. Now these two terms have dy by dx. Please take dy by dx as common. You are left with sine 2y minus x sine xy is equal to y sine xy. Now this term, it will go on the other side of the equation and it will go in the denominator. So dy by dx is equal to y sine xy whole upon sine 2y minus sine xy. This is your answer. Next question. The question is sine square x plus cos square y is equal to 1. See, as we did in the previous question, if it is written as sine square x, we can write it sine x whole square. So this we are doing it here also. I will write it sine x whole square plus cos y whole square is equal to 1. Differentiating with respect to x on both the sides, we will get d by dx sine x square plus d by dx cos y square is equal to d by dx 1. Now this will be solved in the similar way as we did in the previous question. You will get 2 into sine x power 2 minus 1 into d by dx sine x. So whatever is in the bracket, uska derivative, it will be taken separately, right? Plus cos y whole square, it will come out to be 2 cos y power 2 minus 1 into d by dx cos y is equal to d by dx 1. Answer is 0 because 1 is a constant. Now here you will get what is the derivative of sine x? Answer is cos x. Okay, so you will get 2 into sine x cos x plus. So here you will get 2 cos y as it is. What is the derivative of cos y? Answer will be minus sine y multiplied by, the more important thing is don't forget dy by dx, because Generally, the students will write cos y ka derivative, you will write minus sin y, that's it. No, it's wrong, because whenever you will be differentiating y, you have to add dy by dx. I repeat, the answer will be 2 cos y into minus sin y, because minus sin y is the derivative of cos y, multiplied by dy by dx is equal to 0. Now you please open this bracket, multiply it, you will get 2 sin x cos x as it is, minus. So this minus will come here, you will get 2 sin y cos y dy by dx is equal to 0. Right? Now what you do is, you take 2 sin x cos x towards the other side of the equation, and you will get this portion will remain here. You will get minus 2 sin y cos y into dy by dx is equal to, because this is going towards the other side, it will also become minus. You will get minus 2 sin x cos x. Now another formula we will be using. We know that 2 sin x cos x is equal to sin 2x. Okay. So here, instead of writing 2 sin x cos x, I will write minus sin 2x. Okay. Now here also you will be using the same formula, 2 sin y cos y. According to this formula, you will get sin 2y. So here also I am applying this formula only. I will write minus sin 2y into dy by dx is equal to minus sin 2x. Now dy by dx is equal to minus sin 2x whole upon, this will go towards that side. It will come in the denominator. You will get minus sin 2y. Now minus minus sign stands cancelled. The answer comes out to be sin 2x whole upon sin 2y. Next question. Ninth question. See, now you are having y is equal to sin inverse 2x upon 1 plus x squared. In this type of questions, first we have to reformulate the question a little, and then only we will be differentiating. See, put theta is equal to tan inverse x. When theta is equal to tan inverse x, this implies x is equal to tan theta. Now you substitute the value of x, which I have taken as tan theta. So you will get y is equal to sin inverse, bracket starts. Wherever x is written, please put tan theta. Very simple. You will get 2 tan theta whole upon 1 plus tan square theta. So this question has been reformulated in the form of tan. Now we know the formula 2 tan theta upon 1 plus tan square theta is equal to sin 2 theta. See, when you look at the question, you are getting here 2x whole upon 1 plus x square. This way should give you the idea that you have to put x is equal to tan theta, because we have a formula which states that 2 tan theta upon 1 plus tan square theta is equal to sin 2 theta. That is the reason why we put x is equal to tan theta in the beginning. Now taking this and using this formula, I get y is equal to sin inverse this portion as it is, bracket start sin 2 theta. Actually, I have substituted this by sin 2 theta. Now sin inverse and sin will stand cancelled. So I get y is equal to 2 theta. Now when you get y is equal to 2 theta, you replace the value of theta. Theta is taken as tan inverse x. So 2 theta will be written as 2 tan inverse x. I get y is equal to 2 tan inverse x. Now we will differentiate. In the previous questions, in the first line only, I used to write differentiate both sides with respect to x. But the questions which are beginning from question number 9 to the last question, whenever you are getting inverse trigonometry questions, you have to reformulate the questions a little, and then we will be going for the differentiation. So now differentiating both sides with respect to x, you get dy by dx is equal to d by dx to tan inverse x. Now we use the formula derivative of tan inverse x is equal to 1 upon x, 1 upon 1 plus x square. So please put the value, you get 2 as it is, 1 upon 1 plus x square, and you get 2 upon 1 plus x square is your answer. Next question, question number 10. Y is equal to tan inverse 3x minus x cube whole upon 1 minus 3x square. X lies between minus 1 upon under root 3 and 1 upon under root 3. So now what you do is, you put tan inverse x is equal to theta. This implies x is equal to tan theta. Substitute wherever in the question x is written, please write tan theta. So you will get y is equal to tan inverse as it is. Bracket starts 3 tan theta minus tan cube theta whole upon 1 minus 3 tan square theta. Now we know that 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta is equal to tan 3 theta. Now you have to memorize this whole formula, only then you can go ahead with the questions. If you know this formula very well, then on seeing the question here 3x square minus x cube whole upon 1 minus 3x cube, you will correlate this formula to this formula and you will automatically take x is equal to tan theta. And now we know this formula, this equals to tan 3 theta. So I will put the value of tan 3 theta in this equation. I will get y is equal to tan inverse bracket starts tan 3 theta. Now tan inverse and tan will get cancelled. I will be left with y is equal to 3 theta. Now please substitute the value of theta which was originally taken as tan inverse x. So I get y is equal to 3 tan inverse x. Getting this equation, now we will be differentiating both sides with respect to x. dy by dx is equal to d by dx 3 tan inverse x. Now you have to memorize what is the derivative of tan inverse x. Answer is 1 upon 1 plus x square as we did in the previous question. So we get dy by dx is equal to 3 as it is. This 3 will come here as it is. d by dx tan inverse. What is formula of tan inverse? We will put, we will get the answer 3 upon 1 plus x square. This is the answer to the 10th question. Moving further, question number 11. Y is equal to cos inverse 1 minus x square whole upon 1 plus x square. X lies between 0 and 1. Let tan inverse x is equal to theta, which implies x is equal to tan theta. Wherever in the question you are written x, please substitute it with tan theta. So you get y is equal to cos inverse 1 minus tan square theta whole upon 1 plus tan square theta. Now you have to memorize another formula that 1 minus tan square theta whole upon 1 plus tan square theta is equal to cos 2 theta. So substitute the value of cos 2 theta in this equation. You will get y is equal to cos inverse cos 2 theta. If you don't remember this formula, you will not be able to solve this question. Because when you get the question, you have to correlate it to this formula. That is why I have taken tan inverse x is equal to theta. Right? So coming back to the question, I am getting y is equal to cos inverse. Putting this value, I get cos 2 theta. So y is equal to cos inverse cos 2 theta. Cos and cos inverse will get cancelled. I get y is equal to 2 theta. Now substitute the value of theta which was taken as tan inverse x. So I will get y is equal to 2 into tan inverse x. Y is equal to 2 into tan inverse x. Now we will differentiate both sides with respect to x. dy by dx is equal to d by dx 2 tan inverse x. 2 as it is into d by dx tan inverse. What is the derivative of tan inverse? Is 1 upon 1 plus x square. So you get the answer dy by dx is equal to 2 upon 1 plus x square. A very simple question. Moving further, the question number 12. Y is equal to sine inverse 1 minus x square whole upon 1 plus x square. X lies between 0 and 1. Now let x is equal to tan theta as tan inverse x is equal to theta. Now wherever x is written, please put the value of x which is tan theta. You get y is equal to sine inverse 1 minus tan square theta upon 1 plus tan square theta. Now another formula to memorize is 1 minus tan square theta upon 1 plus tan square theta is cos 2 theta. Kindly substitute the value. You will get y is equal to sine inverse cos 2 theta. Now we know that cos theta is equal to sine pi upon 2 minus theta. Another formula you have to learn. But here in the question we have 2 theta. So if cos theta is this, so cos 2 theta is going to be automatically sine pi upon 2 minus 2 theta. Wherever theta is written, you have written 2 theta. Put the value of cos 2 theta in this equation, you will get y is equal to sine inverse sine pi upon 2 minus 2 theta. Okay, now this sine and sine inverse will get cancelled. You are left with y is equal to pi upon 2 minus 2 theta. Now substitute the value of theta which was taken as tan inverse x here. Because theta is tan inverse x, you will get y is equal to pi upon 2 multiplied by tan inverse x. Now comes differentiation, both sides with respect to x, you get dy by dx is equal to d by dx pi upon 2 minus 2 into d by dx tan inverse x. Now what is the formula of tan inverse x is equal to 1 upon 1 plus x square? Kindly put the value. D by dx pi upon 2 is held as constant. The answer will be 0. So the derivative of pi upon 2 is 0 minus 2 as it is. Multiplied by 1 upon 1 plus x square, you get 0 minus 2 upon 1 plus x square. Answer is minus 2 upon 1 plus x square. Moving on to the 13th question. Y is equal to cos inverse 2x upon 1 plus x square. X lies between minus 1 and 1. Now, substitute x is equal to tan theta, which implies theta is equal to tan inverse x. Substituting the value of x, wherever x is written, you will write tan theta. You get y is equal to cos inverse 2 tan theta whole upon 1 plus tan square theta. Now another formula, we know that 2 tan theta upon 1 plus tan square theta is equal to sine 2 theta. Substitute the value, you will get cos inverse is equal to sine 2 theta. Another formula, we know that sine 2 theta is equal to cos pi upon 2 minus 2 theta. Right? So we will substitute this value, we get cos inverse, bracket starts cos pi upon 2 minus 2 theta. Cos inverse and cos will get cancelled. We get y is equal to pi upon 2 minus 2 theta. Right? Now substitute the value of theta, which was originally taken as tan inverse x. So I get y is equal to pi upon 2 minus 2 tan inverse x. Differentiating both sides with respect to x, dy by dx is equal to d by dx pi upon 2 minus d by dx 2 tan inverse x. Now this answer is 0 because it is considered a constant. Minus 2 d by dx tan inverse x. What is the derivative of tan inverse x? It is 1 upon 1 plus x square. So the answer is 0 minus 2 upon 1 plus x square. Answer is minus 2 upon 1 plus x square. This is the answer to the 13th question. Now comes the 14th question. Y is equal to sine inverse 2x multiplied by 1 minus x square under root, where x lies between minus 1 upon 2 under root and positive 1 upon under root 2. Let sine inverse x is equal to theta. This means x is equal to sine theta. So y is equal to sine inverse 2x into under root of 1 minus x square. Substitute the value wherever you have written x in the question, you will write sine theta. So you are left with y is equal to sine inverse, bracket starts 2 into sine theta under root of 1 minus sine square theta, because here is x square, so you will write sine square theta. Now you know that 1 minus sine square theta is equal to cos square theta. Please substitute the value. In this place you will write cos square theta. So you get y is equal to sine inverse 2 sine theta as it is multiplied by cos theta, because here you will write cos square theta, which will get automatically cut with the under root. This square will get automatically cut with the under root. You are left with cos theta. Y is equal to sine inverse 2 sine theta cos theta. You know that 2 sine theta cos theta is sine 2 theta. Substitute the value, you will get y is equal to sine inverse sine 2 theta. Now this sine inverse and this sine will get cancelled. You are left with y is equal to 2 theta. Now put the value of theta, which was originally taken as sine inverse x. So y is equal to sine inverse x, because theta is equal to sine inverse x. Y is equal to 2 into sine inverse x. Differentiating with respect to x on both the sides, you get dy by dx is equal to d by dx 2 sine inverse x. This 2 will come automatically outside as it is, multiplied by, what is the formula for sine inverse x is 1 upon under root of 1 minus x square. So it is 2 multiplied by 1 upon under root of 1 minus x square, which is the answer. Dy by dx is equal to 2 whole upon under root of 1 minus x square. Last question, 15th. Y is equal to sec inverse 1 upon 2x square minus 1, where x lies between 0 and 1 upon under root 2. So let cos inverse x is equal to theta, which means x is equal to cos theta. Substitute the value in the question wherever x is written, please put cos theta. So you are left with y is equal to sec inverse 1 upon 2x square minus 1 will be rewritten as sec inverse 1 upon 2 cos square theta minus 1. Okay. Now we know that 2 cos square theta minus 1 can be written as cos 2 theta. So you get y is equal to sec inverse 1 upon cos 2 theta. Now cos 2 theta is the reciprocal of sec 2 theta. So I can write as y is equal to sec inverse sec 2 theta. Sec inverse and sec will get cancelled. You are left with y is equal to 2 theta. Now substitute the value of theta, which is cos inverse x. You will get y is equal to 2 into cos inverse x. Differentiating with respect to x on both the sides, you will get dy by dx is equal to d by dx 2 cos inverse x. 2 will come outside as it is, multiplied by d by dx cos inverse x. Now the formula for cos inverse x is 1 minus 1 upon under root of 1 minus x square. Please put the value. You will get 2 into minus 1 whole upon under root of 1 minus x square. So your answer comes out to be minus 2 whole upon under root of 1 minus x square. So it is my advice to you that whatever formulas I have used in this article, write down on a pen of paper and just memorize them thoroughly. Only then you will be able to apply these formulas in these equations. Otherwise, the exercise will seem very tough to you. But once if you learn this formula, then this exercise is damn easy. So here comes to the end of the article. Please subscribe to my channel. Feel free to ask any doubts in the comment section. Thanks for watching. Stay safe, stay blessed.